Welcome back, Cat 5 class. We're going to go over problem 822. So we're going to create our views. We're going to create 3 views and use the dimensions here to dimension our 3 views. And this is in millimeters. All right, so let's get started. Take a look at the 3D model. Okay, so we're going to call this the front view, side view, back to the front view, and top view. Okay, so we have these 2 holes, and we also have this cutout here. All right, so let's go ahead and take a look at the front view. Let's actually cheat and look at the answer key. All right, so we have the front view. We have hidden lines to represent the holes, and also this opening. Okay, we have the hidden line. Hidden lines also here for the opening. And we have the hidden lines for the holes. All right, so let's get started. Let's take a look at the AutoCAD file. Okay, so it's partially complete. Okay, so we have our front, side view, and our top view. Okay, so the front looks pretty complete as far as the object lines. Same thing with the right side view. There are a few object lines missing in the top view, so let's take a look at that one. Okay, let's take a look at the 3D model, top view. Okay, we are missing the hole, and we're also missing a few hidden lines and center lines. Okay, so let's go ahead and insert the hole. Okay, so let's go to the visible object layer and draw a circle for the hole. The large circle is a shaft, it's a solid. So now we're going to draw the hole using the circle command. So we're going to use the exact same center as the large circle. And there's the hole. All right, I think we have all the object lines. Yeah, it sure seems that we have all the object lines. All right, so let's go ahead and draw some hidden lines. Okay, so let's go to the hidden layer. And let's draw our hidden lines, line command. Okay, so we have this hole going all the way through, right? So from this quadrant, we're going to go straight down and draw our hidden line. Right click enter. You can hit spacebar to repeat the command, in this case the line command. So from the right quadrant all the way through, right click enter. Okay, now let's repeat the same for the other hole. Line command from the left quadrant, go straight down. Same thing for the right quadrant. Okay, and there we have it. Now we're not done with the red hidden lines in this front view. We also have this opening here that we need to account for using a red hidden line. So let's use line command. Again, from this vertex, we can now show that cutout as a hidden element. Okay, right click enter. Okay, so that took care of that opening. Everything lines up. Okay, so now let's go ahead and throw in our center lines in this front view. Go to center layer, line command, and always go a little bit slightly beyond. Okay, now we need a center line for this hole, right? So center line is from the center straight down, and now from this center straight down. Okay, and that represents the axis of the hole. All right, so we took care of that. All right, do we have anything else missing in the front? I think we got everything in the front. Let's take a peek at the answer key. Okay, so we have our hidden lines, center lines, hidden line, center line, and a hidden line. No center line for the rectangular cutout, right? We have the center line for the axes of the circular holes, right? Okay, looks like we have everything. So now let's go ahead and let's move on to the top view. Okay, so let's throw in our green center lines and hidden lines. So let's do our center lines first in the top view. roll the wheel to zoom in and out. All right, so let's go ahead and draw our green center lines. So let's go to center layer. Okay, we're already there. Go to annotate. Let's use the center mark. And instead of clicking on the little circle, we're going to go to the large circle because they share the same center line. We're going to have to extend it. It's a little too short. And let's do this one also. And hit escape or enter to exit the command. So let's go ahead and extend these. Let me turn off object snap so I can have more freedom to extend. And again, the grips, my settings for the grips are too large, but I increase them just for lecturing. All right, so we're good there. All right, hit escape to deselect. Let's go to the next one. And let's go ahead and extend this one. And this one we can go all the way across. Since we have a symmetrical part, might as well extend it to show symmetry. All right, let me hit escape. Okay, so we got the center lines. All right, so now we need to take care of the hidden lines. Okay, so for the hidden lines, we have this thickness, right, on this wall that we need to represent with the hidden line. So let's go to the hidden layer, go to the home tab, go to hidden layer, use the line command, go to the vertex. Let me turn on our object snap. So from this vertex, we're going to go straight up. There it is, right click enter. So that represents the thickness of the wall. Okay, so we need now to represent the opening in the top view. So if we go back to the 3D model, so from the top view, we already took care of the red hidden line for the inside edge here that we don't see from the top view. And we now need to represent the opening with the set of hidden lines. Okay, so let's go back to AutoCAD. All right, so using the 45, right? So 45 from the vertex of the box for the front view, right? We draw 45, and that way we line up our top and side view. All right, so using the line command, let's go ahead and go to the opening. From the side view, go straight up, hit the 45 and go across, and it goes the thickness of this wall. Okay, so we're going to stop right there. Right click enter, repeat for the opposite side, line command, from the corner, go straight up, right click enter. Okay, so there it is. We have our red hidden lines. Let me get rid of the evidence that we cheated. Oop, I misclicked. Let me hit escape. Misclicked. I want to make sure I get the red hidden lines and delete them. And I can shorten the set of red hidden lines. All right, so let me hit escape. Okay, so looks like we took care of all the red hidden lines and we got all the center lines. Let's take a look at the answer key once again. Let's take a peek. It's not like we're cheating, right? We're just taking a peek. There it is. We got the red hidden lines, center lines, object lines. We have everything. Okay, so now we need to complete the right side view. So we definitely need this red hidden line from this corner. So we cannot see this surface nor the edge here, this inside edge. So we're going to represent it with the red hidden line. And then we need to bring in the red hidden lines representing the two holes. All right, so let's go ahead and throw in the red hidden lines and a center line. All right, so let's throw in the red horizontal hidden line. So use line command. From this corner, go across. And there's our red hidden line. Right click enter. All right, so now instead of having to draw the red hidden lines and center line and going across, hit the 45 and go straight down. See, that's the safe way of doing it. But I'm going to cheat and use the ones that we have here. It's the same holes that we're going to represent in the side view. So we're going to represent these hidden lines for the hole and its center mark. Okay, so now we're going to use the copy command. Copy. I'm going to grab it from this intersection. There it is. The green center line and the white visible object line go straight across to its center. There it is. And click. And we have it. It's centered. Okay, so right click enter to exit the command. So there we have the long hole going all the way through the shaft and the rectangular portion. Okay, so let's go back to the 3D model. So we just took care of the yellow hole at the top going all the way through. So you can see it goes all the way through the shaft and through the rectangular solid. And now we need to represent this hole. And they have a slight larger diameter. It appears for this one. Okay, this diameter seems larger than this diameter. Okay, so let's go ahead and draw this hidden hole, it does seem to have a larger diameter than this one. Okay, so we'll find out in a minute. Let's go ahead and copy it over. Okay, so we'll pick this intersection point and go across. And there it is. Click. And yes, if we zoom in, we can see that the diameter for the short hole is larger than the long hole. All right, so we can hit escape. Now we have center lines overlapping each other, so we need to, we can leave it, but let's go ahead and get rid of one of the center lines. They're overlapping. Let's just delete one of them. And now we can extend it all the way through because we have a symmetrical part here. Okay, hit escape to deselect. All right. So it looks like we have everything. Let me turn off the construction lines. All right, so it looks like we have everything for all three views. Now we can go ahead and dimension. All right, so notice let's take a look at the top view first. So top view, notice that they are dimensioning right to left. So 35, 80, 110. So the reason they're dimensioning from the right and not the left is because the right has more surface area than the left. All right, so let's go ahead and start adding dimensions right to left. We'll add the diameters for the holes. Notice we only add diameters for circular holes, but not circular shafts. Since this circle represents a shaft, we need to place the dimension down at the front view, the rectangular view. Go back to your lecture notes in case you forgot about rectangular views versus circular views. All right, so let's go ahead and do some dimensioning. All right, so let me zoom into the top and let's go to the dimension layer. Okay, so let's go ahead and from here, the shortcuts to dimensions, the annotation panel, and go to linear dimension. And we're gonna go from right to left. Okay, there's the first one. Okay, let's go to the second one. And again, space it out. Actually, I should space it out a little bit further. Let me hit escape. Okay, you want it to look presentable. Hit escape. There it is. All right, let's throw in another linear dimension from this. Again, this is our datum here. So we'll pick the corner and it automatically adds a gap. Okay, let's go to the next center hole. There it is. And space it out, make it look presentable. Notice how it automatically generates a gap. And that's based on our settings. So it's following a standard. All right, so now let's go to the next dimension. And we're gonna go with the overall dimension. And there it is, it looks evenly spaced out. Notice that the first dimension has a larger spacing, and then from there on, you try and keep it consistent, about one text height apart. All right, so, and once again, don't forget, you try and dimension the small ones first, and you work your way up to the older siblings, right? The longer dimensions. Okay, let's throw in our diameters. All right, so if it's a complete circle, you go with diameter, right? And it has to be a hole. There it is. Place it. Go to the next one. Click on it. Oh, I just realized that I have Object Snap turned on. No wonder I was getting a little bit of snapping. So let me turn off Object Snap or Snap to Grid. There it is. That's the reason I was having issues on the previous videos, misclicking. All right, and space it out, right? About 2 text heights, 1, 2, and so on. There it is. Just eyeball it. Notice how the arrow is always pointing towards the center. And we do not put a diameter on this large circle because this is not a hole. This is a shaft. All right, so now we need to throw in the overall depth. Now this cheat, take a look at the answer key. Notice how we don't have a depth here or a radius here like we did on one of the previous problems, right? If we go back, here we have a radius of 0.88. This is the previous problem. So these are considered double dimensioning, so one of them has to be placed in parentheses. So in this case, we don't have a radius, right? So we need an overall depth. We can place it here or place it here. Okay, so let's go ahead and place the depth of 55 millimeters. And then we need to locate these symmetrically. So that's where the 27.5, which is just half of 55. And we'll put our dimension with respect to the center line. Okay, so let's go ahead and do that. Okay, so let's throw in the small dimension first. So linear. So linear is for vertical or horizontal lines. Okay, so from this vertex to this endpoint, there it is. We need to come back and add the 0.5. We'll do that next. Let's first throw in the overall dimension for the depth. Okay, since the back and the front have the same amount of surface area, we could have dimensioned the 27 from this corner to the center line, or again, this direction. So either one will work. All right, so this one, we should add a decimal place. So I'm going to click on it first, select it, and then you right click and go to precision. Okay, so go to precision and you can go to 1 decimal place. Ta-da! There it is. All right, did you blink? Rewind the video and you'll see how we added that 0.5. All right, so let's go on to the next one. All right, so let's go ahead and throw in the diameter for the shaft. Once again, we do not dimension the circle here because it's a solid. So we need to dimension it on the rectangular view. So this has a diameter of 46. So we're going to throw in a linear dimension. Okay, so linear dimension, point to point. There it is, 46. And we're going to double click, and make sure it's blinking towards the front, or use the arrows on your keyboard to go all the way left, using the left arrow all the way left, and we can insert diameter. There it is, and then click out in space to exit. And let me hit escape to exit the entire command. There it is. All right, so let's take a look at the answer key again. All right, so we have a surface area here and one at the bottom too. Which one has more surface area? So here you have this surface area on top. This one has a longer surface area, so this makes more sense to dimension from the bottom up. But we should be able to also dimension from the top down. They both have about the same surface area. Right, this surface area goes all the way across. And then we have all this surface area, but either one should be fine. All right, so let's go ahead and dimension bottom to top, and bottom to the very top. And then we'll also bring in the thickness of the wall. All right, so let's go to linear dimension. So let's go bottom to top. Okay, and always leave enough space for the first dimension. You put double the space. Go to the next dimension. And you work your way up from the small dimensions to the larger ones. And now here we can use 1 text height of space. And finally, the overall height. And space it out so it looks presentable. There it is. And once again, I have to mention this because some of you will make this mistake. I don't want to see a extension line on top of a object line like that. It's okay if you cross an object line. That's okay. That's acceptable. This is not acceptable. You don't want to see an extension line on top of the object line. That's incorrect. So we need to go back and shorten it. There it is. Hit escape to deselect, and there's the gap. Okay, now we need the thickness of this wall. So linear dimension, corner to corner. Okay, so we can either bring in the 20, bring it inward using the grips if you like. I'll leave it up to you on that one. You can play around with this if you want to move the arrows outward or bring in the text, or leave it the way it is. All right, so now let's go to the right side view. Okay, so we need a dimension for the opening, right? So we need this dimension and this dimension. All right, so some of you are probably wondering, well, how come we don't put in this dimension for the opening? Well, we can calculate it. It's just 40 minus 15, which is 25, right? So 25 is this dimension. We can just simply calculate it, so we leave it out. Now, one thing you can do is make this 15 and this one 15. That's one option. But the way it's dimensioned here, it's telling us that the 40 is more important than two 15s, or a 15 and a 25. Now, if something had a slide in here, if there's a block that had a slide in here, or maybe this has to slide along a rectangular block, then you would put the 25 and get rid of the 40. Okay, so, but we don't have any information regarding a part that mates with this one at the rectangular cutout, so we can just leave it the way it is. Okay, so if you don't have any information about what attaches to this part, then you can just simply pick a datum, go right to left, right to left. This case, the datum on the left has the same surface area as the right, so we can also dimension 15 left to right and 40 left to right. Either one will work. All right, so let's continue on. So linear dimension, go to the vertex, okay, there's the 20. If you want to bring it in, just click on it, use the grips, and slide it inward. And let's put some more spacing. There it is. Hit escape. And you can always flip the arrows, right, if you want. Try and see if it looks good. You can just hover over the grip until you see flip arrow. Oh, I missed it. Okay, that looks a little too tight, as you can see. Let me hit escape. Yeah, that's way too tight. It looks tacky, right? Well, those are some ugly curtains on the window. You know, they're criticizing your home. It's all right. Let's rearrange it or replace them. So we can always hit undo. There it is. Okay, so I'll leave it up to you on the location of the arrows and the text. All right, so now let's go ahead and dimension this opening. Linear dimension. Okay, so we're going right to left. And let me go ahead and use the grips on this one to move it over. And let's throw in the next dimension. Corner to corner. And space it out, make it look presentable. All right, there it is. Okay, so it looks like we're pretty much done. Let me double click to do a zoom fit. All right, so let's take a look at the answer key. Okay, looks like we're done. We got all the dimensions. Yes. All right, so now let's say your boss tells you, okay, we know this is in millimeters, and they tell you, you know what, let's do this in inches. So this drawing is in millimeters. If we look at the handout, you can see this in millimeters. So it is common sometimes to switch over and say, hey, instead of millimeters, let's go with inches. The machine shop that's going to make this part for us, that's going to machine it for us, they don't like millimeters. They want to go with inches. All right, so let's convert this to inches. You don't have to do this part. I just want to show you how to do it. So if we go to the notes, if you want to make any changes to your settings, number of decimal places, you want to change from inches to millimeters or vice versa, you want to go to the Annotate tab, Dimensions panel, and click on this downward arrow, and that'll take you to the Dimension Style Manager window. And we can modify, right? We can modify the standard. Okay, so the first one is the first tab is for lines and spacing, right? And symbols and arrows. Let's go to the next one. That's if you want to extend your center marks when you add a radius or diameter. This is the size of the arrowhead. You don't want to change the size of the arrowhead. Let's go over to text. Okay, text height, which is the same length as the text, as the arrowhead. My mistake, the arrowhead is 0.18 in length, just like the text, and we're following an American standard here. If it's millimeters, it's usually around 3 millimeters. Okay, so you don't want to change arrows nor text. If you do have to change them, you want to go to the Fit tab. So the Fit tab, we have overall scale. If you want to change the size, text height, arrow length, gaps, extension lines, you want to do it here at overall scale. Okay, so if you want to change it from millimeters to inches. Oh, by the way, on a drawing, you always want to, in the title block, call out what type of units you're using. 99% of the time, in manufacturing, aerospace, automotive, you're going to use either inches or millimeters. All right, so this is our scale factor. You go to primary units. This will allow us to change our decimal places for precision. And we can see it in the preview, and I'll demonstrate that. Our scale factor. So if you're going to use inches or millimeters, remember that we have 1 inch equals 25.4 millimeters, or 1 millimeter equals 0.03937 inches. So in this scale factor here, if you're dealing with strictly millimeters or inches, you're going to input one of these numbers, 25.4, 1, or 0.03937, right? That's just 1 divided by 25.4 is 0.03937. Okay, so that's the scale factor. Also, we have leading zeros. Don't forget, if you're dealing with millimeters, we do put zeros in front of the decimal if it's a number smaller than 1. If it's inches, you don't put a 0 in front of the decimal for a number smaller than 1. All right, so let's go back. All right, so just a reminder, if you're dealing with inches, like this is 0.62, so one of the previous problems, 0.62, this is inches. Notice that there is no 0 in front of 0.62. Same thing with 0.38. There's no 0. If this was millimeters, we would put the 0 in front of the decimal. Okay. All right, so once again, your boss says, hey, I changed this from millimeters to inches. All right, so let's go back to AutoCAD and go to the Annotate tab. Go to Dimensions panel, click on the little downward arrow, be patient, there it is. We're going to modify the standard. So a standard can be an American standard, an international standard, or a Japanese standard. Okay, so let's go ahead and modify. Okay, so let's go over to, first let's go to the Fit tab. I want you to notice that the size of the text is 25 times larger than the regular scale of 1. Watch what happens if I drop this down to 1. Then I'll come back and do the primary units. Okay, so Fit tab, overall scale, we're going to drop it from 25 down to 1. And okay, and watch what happens and close. See, it scales down the text and the arrowheads down by a 25th. Okay, notice the arrows, right? So if your dimensions come out too tiny or way too large with respect to your views, then you go to the Fit tab. So let's go back. Modify the standard. Go to the Fit tab. Go to overall scale, and we can use 25, 30, nothing to do with 25.4 millimeters equal 1 inch. Just a coincidence that I used 25 for this one. Let's go with 30. Let's go to scale factor of 30 times. And let's now go to primary units. So we'll leave this at 30 times. Go to primary units. All right, so here's our scale factor. So if we're going to drop this down to inches, let's go down to, once again, 0.03937. So for the scale factor, 0.03937. And you're going to see the numbers change from millimeters to inches. And we don't want to put any leading zeros, right? So we want to suppress zeros in front of the decimal when we're working with inches. Okay, so suppress leading zeros. Why? Because we're switching over to inches. All right, so let's hit OK. And don't blink in 3, 2, 1 to close. And bam, there they are. Now we're in inches, but you know what? We should add 2 decimal places. When dealing with inches, if you don't know how many decimal places to use, start with 2 decimal places. That's a good starting point. Okay, so let's change these to 2 decimal places. Let's go back. Go to Annotate tab, Dimensions panel, little arrow. Now we have the Dimension Style Manager. Let's modify the standard. And we're going to change the decimal places from none to up to 2. And you can see it in the preview. And OK. And close. And there it is in inches. And now we can make some more room, right, for the dimensions. There's plenty of room here. You can always move the views apart to make more room. All right, so space these out a little bit more. Okay, so that's the way you switch from inches to millimeters, or in this case, millimeters to inches, and hit escape. All right, so that's the end of this video. Don't forget to save your work. End of video.